I've got the ancient VGA monitor on the desk, so that can only mean one thing, right? It's server board time! Okay, this is a new Xeon 6 board, the Gigabyte MW94-RP0. That's why you're here, right? You saw the title, the search found you. We're going to take a quick tour of this motherboard. A lot of Gen 5 connectivity, and it's a good Gen 5 platform for Xeon. We're also going to do some benchmarking, see how this thing stacks up. Up to 350 watt TDPs, 8 memory channels. You know, there's a lot to look at here. In case you've been living under a rock, Intel launched their new Xeon 6 platform for workstations, which include overclockable processors. This is not a motherboard you want for overclocking. It's 350 watt TDP as a hard cap. You know, when we're talking about overclocking, RDIMMs, that sort of thing, that's not this board. That said, this is an affordable workstation board. You have 6 PCIe Gen 5 slots, plus these 2 PCIe Gen 5 headers. That's why you want this board. That's why you want this platform, is so that you can host and connect a lot of PCIe Gen 5 peripherals. And yes, you can split the lanes here, 16 lanes in a PCIe Gen 5 slot, or 2 groups of 8 lanes, or 4 groups of 4 lanes for NVMe or graphics cards or whatever. Now, you do have to get a little creative if you're going to cram in a bunch of Gen 5 GPUs on this thing. But the slot arrangement here does properly support 4 double-wide GPUs. So you can build a workstation around this. And if you want to learn more about Xeon 6 as a platform, we did some benchmarks when that platform launched. You should check it out. That was with a 24-core CPU. For today, we're going to be testing a 48-core CPU. And things were weird. Things are a little bit weird with those CPU launches. I picked up a couple of Xeon 6 CPUs on eBay. I've also borrowed a 48-core Xeon 6 CPU from Gigabyte. The reality with the, you know, just like these, there's no such thing as samples in this. You know, like, hey, show me, let's do the benchmark. Let's look at this. It's not, 2026. Everything that can be made is being sold. And there was really not a huge difference from 12 or 16 cores all the way up to 24 or 48 cores with Xeon 6, except for, and 60 cores and beyond, except for you get 4 or 8 memory channels, and you get the overclockability with the X CPUs. But again, you can put X CPUs in this. They're just going to be limited to 350 watt TDPs. Our DIMM configuration here, 6400 mega transfers is officially supported, unless you use multi-ranked DIMMs. And then multi-ranked DIMMs are DDR5 8000. The march of technology has continued even in the enthusiast drought. And like businesses still have to build servers and still have to qualify servers and that sort of thing. And so Gigabyte and everybody else are cranking out this sort of stuff literally as fast as it can be produced, because what are you going to do? I mean, it's like you if you're a business and your business depends on it, you have to buy it in order to keep doing your thing. Even if you're not involved in AI, like you server breaks, something like that, you got to do it. And it is nice to see platform updates where it's like, oh yeah, 6400 memory. It's just old hat with low latencies. It's like, that's where we are now. This board also has a number of other notable features, and that is it has 5 M.2 that support up to 22110 that are arranged around the board for cooling. They're also, the M.2 and the connectors are also arranged such that you can hang a card off of the end, because we've got the right angle connection for the front panel. There's 4 fan headers here at the bottom, and then some other fan headers scattered around the board. 7 fan headers in all, which are controllable from our ASpeed 2500. And of course, at the rear I/O, we have our dual 10 gigabit interface thanks to our Intel 710. We do have audio on board and a front panel audio connector, because again, this is aimed more at workstation. You could use it as a server, rack mount configuration. Some people have racked workstations. That's fine. RS-232 serial, VGA for our out-of-band management, which is nice. Pretty good selection of USB Type A ports and a Type C port here at the rear. Our out-of-band management network interface here on the top. We also have an onboard front panel Type C connector, which is really nice to see. So you can do front panel Type C, and then as well as the 20-pin 5 gigabit header at the bottom. Intel does still support software RAID. There's a software RAID header there that is now handled by G-RAID. I reviewed G-RAID a bunch in the past, and they have taken over the last vestiges of Intel software RAID, Intel RST. And this can be a compelling option for software, like things that need software RAID. As far as I know, Intel has literally the only supported NVMe RAID solution that doesn't require add-in hardware, which is actually slower, for VMware. So if you wanted an absurdly fast 8 or so drive, like 8 Gen 5 NVMe, like our Kioxia high-end storage, you could build that around what G-RAID offers. And this platform will let you add the hardware key for that. Or if you're going to go with the G-RAID option, you'll actually add in a single slot GPU, and then that'll do GPU-based acceleration of RAID and that sort of thing. If you're going to run Linux, you're going to be using Linux MD, you'll be fine. Power connections for this motherboard are pretty standard. You got the 2 standard CPU 8-pin power connections plus ATX. Also, these SlimSAS connections at the front here, these are for SATA only. So there's 2 groups of 4 SATA ports here on the SlimSAS 4. The SlimSAS 8 is 8 PCIe Gen 4 lanes, but that comes from our W890 chipset. So these lanes are from the chipset. Everything else, the platform up to 128 lanes, comes from the CPU. I will also point out, if you are building a workstation from this, you are going to want to use a case that has an absurd amount of airflow. Big fans in the front. Why? Because the fans for our VRM 350 watts are really not that large. This is designed for a lot of airflow from front to back, like a server configuration. And if you are going to build a workstation around this and you are going to get a nice case for it, make sure that you have ample amounts of airflow from front to back. This is an unusually large motherboard, so you will have to carefully consider the motherboard layout and mounting holes when you are considering your case. I might suggest Silverstone would be a good option, but you will probably have to add higher CFM fans to your Silverstone tower case. Something like the Ceda H2 or one of their rack mount cases would probably be a good option, but you will, I promise you, need to upgrade the airflow because you need a lot of front to back airflow. This is our torture test platform. I'm using a Noctua tower cooler because it's a torture test platform. Now, for the testing on this one, it's a little odd because of the connections to the motherboard and that sort of thing. So it's using Kioxia U.2 with our dual, this is MCIO breakout. Now remember, this motherboard has the PCIe Gen 4 / SlimSAS style connections at the front. Those are mostly for SATA, although the other 8-lane port is configurable and flexible, remember. And then we've got the 2 MCIO ports at the front. So this motherboard can be a good choice for 4 GPU configurations. You know, you get the 3 and 3 slot grouping, 6 slots here, but you could run 4 X16 GPUs with the PCIe layout. Also notice that the PCIe layout on this platform does support down to X2 bifurcation. So depending on the chassis and the specific hardware configuration, you can break these X16 slots into 8 2-lane connections. Why would you do that? Well, it turns out that a lot of PCIe Gen 5 storage only uses 2 lanes, especially if you're building a big storage server and you're going for the capacity play as opposed to the density play. Having a chassis that has a bunch of, E1 or E3 storage at the front may only connect with 2 lanes instead of 4 for your storage configuration. And so this motherboard supports that. Now, DDR5 6400 was what I was most interested in testing in this because that's the fastest memory that I have. I don't have any 8800 MR DIMMs, and Xeon 6 supports some really neat stuff with the memory configuration. So 6400, I'm happy to report on this platform, perfectly solid, tested up to 64 gig DIMMs, tested 8, 16, 32, and 64 gig DIMMs. Nothing untoward to report there, which is fantastic across both SK Hynix and Samsung. Now, why am I telling you that? Well, the Xeon platform, the Xeon 6 platform, is sort of unique and interesting in that it supports something called sub-NUMA clustering, where you can turn that on and get more non-uniform memory access groups, more NUMA groups, and that will lower your effective memory latency. The highest and best calling for the Intel platform, if you don't need Intel specific extensions for performance like AMX, is relatively low memory and platform IO latency. This can be really good for storage. This can be really good for mixed storage and GPU workloads. This can be really good for AI workstations. That is what works really well. Because if we look at our 658X CPU, 48 Xeon 6 cores, it lands somewhere between the 32 and 64 core Zen 5 Threadripper. Xeon 6 goes handily toe-to-toe with Zen 4, but falls short of Zen 5 in a lot of key benchmarks. Where Intel makes that up is memory bandwidth, memory throughput, I/O for GPUs, PCI Express, 16 lane configurations, that 4 GPU configuration that I was telling you about, and places where you can take advantage of Intel's AMX extensions. Sort of funny, AMD is ahead with AVX 512, and the AVX 512 instructions that AMD supports on Zen 5 can be significantly ahead of Xeon 6. When I was first reviewing Xeon 6 and when I first put it together, like I said, I was able to pick up some CPUs at a pretty good deal, and they were priced aggressively. And so it's going to depend on what, like if you're shopping, you're going to have to do some comparison shopping here and look at the costs and the cost of the platform and the other stuff to decide which one is giving you more compute per dollar. Because when Xeon 6 first launched, Intel had positioned Xeon 6 to give you more compute per dollar. But in, July of 2026, I'm doing that comparison shopping, and it seems like the Xeon 6 CPUs are a little harder to attain in standard workstation configurations. And so I've had to get a little creative sourcing some of the Xeon CPUs that I'm using for testing. But still, I think the 24 to 48 core configuration is the sweet spot, and especially the 24 core Xeon 6 platform can give you more memory bandwidth and more I/O than the equivalent AMD 24 core platform. But 32 cores and on up, the cores are able to keep the platform and everything else fed. And Intel is doing a little better in that regard on a per core basis, even though the absolute top clock speed maybe doesn't come in there. Still, it's nice to see this platform. It's nice to see the out-of-band management, the dual onboard Intel 710 NICs. It's the Intel X710. Pretty awesome NIC, pretty awesome configuration. I did also try running an E810 off of MCIO to PCIe adapters. That does work, although there's a couple of quirks in the BIOS in terms of surfacing the MCIO header. The MCIO header is configured for X4, X4. Maybe I want to configure it for X8 and PCIe lanes and something like that. I'm sure that that's something you can do that through the UPI register, but that's also something that should be more exposed in BIOS. So probably in a BIOS update, Gigabyte will give you that, and that will work pretty well. But like I say, this is meant to be an all-rounder workstation-ish platform with no overclocking features. And so because it's no overclocking features, you'll also want to pair this with JEDEC DDR5 memory, which is why I tested a whole bunch of JEDEC DDR5 memory. Kingston also pretty good support here because they have the JEDEC profiles, but remember 6400 here is a JEDEC profile. If you are using RDIMMs that are 6400, like the Kingston Gamer 6400, those are actually 4800 or 5600 for the XMP profile, and it's an overclock to get to 6400. That does not work on this platform. You'd get 48 or 6400. 6400 JEDEC, however, does work. Those are looser timings, something to keep in mind. So overall, torture test on our platform, it's pretty good. I like the fact that you got 4 Gen 5 M.2s on board. You can configure that as a RAID 10, your operating system of choice, which my operating system of choice on this platform, Linux, 100% Linux. And good kernel support all the way from 6.7, 6.18, and the 7 series, which is what I tested here. Pretty good support, no untoward behavior, good IO MMU separation, good ACS, PCIe ACS control. You still get a little bit better performance if you disable IO MMU altogether, and you're going to run this in a more dense GPU configuration. But there you go. Other little nice features, the fact that you got the right angle connectors on the bottom that I mentioned before. You'll be able to run this in those Silverstone like workstation rack cases, and I think that'll work really well. Also, like I say, this thing is meant for server levels of airflow. We got a fan on the front on our workbench that is keeping everything adequately cool. And I needed a second one here at the back because the VRMs at the back will get quite toasty without server levels of active airflow. So if you're building a workstation around this, be sure that you manage the front to back airflow in this configuration. An Arctic tower cooler would be a better choice in this configuration versus the Noctua because of that configuration. I chose the Noctua for this build. The Noctua cooler is good, like it's effective. It's just that you wouldn't want to build around it in this configuration because of the airflow that this motherboard basically demands. But I needed to test a lot of memory, and I didn't want to dismount the cooler. So it's really easy because I can just pop the fans off and be good to go. The Arctic cooler sticks out over the memory and makes it problematic to change the DIMMs. But check out Arctic's website for their tower coolers that work really well on this platform. Love the USB layout, love the 10 gigabit, love actually testing it and being able to get the full 10 gig interface. They're taking advantage of the platform features that Intel offers there. So it's nice to see that. And that's pretty much it for this one. If you want to see more benchmarks, more specific benchmark results, check out the Phoronix benchmarks that I've uploaded for this platform. Everything is pretty solid. It's about where you'd expect workstation wise. There's really not a lot else to say about this platform, this motherboard from Gigabyte, and the different configuration options that it affords you if you choose to build around this particular motherboard. So I'm Wendell, this is Level 1. It's been a quick look at the Xeon 6 platform. Again, it's pretty awesome, although, you know, there's it's like I need a new platform. Like, I'm Wendell, this is Level 1. Existential issues notwithstanding, Xeon 6, it's looking like a pretty interesting platform. It's shaping up. I definitely like Xeon 6 better on the server platform than I do the workstation platform, but it's got it where it counts on the workstation platform. I think this would be a good option, especially for those non-overclocking Xeon 6 CPUs. I'm Wendell, this is Level 1. I'm signing out, and you can find me in the Level 1 forum.